All right, there we go. Since this comes into focus, I'll get started. All right, so today's lesson is 2-6. This is ratios and proportions. And on my class notes, there's some definitions. You please need to take a look at those and make sure you understand those. I want to just get into problem solving here. One of the first things that I'm going to hope that we will be able to do is to determine if ratios are equivalent. And to do that, we cross multiply. So if I give you two ratios set equal to each other, and I ask that we multiply this to determine if they are equivalent, that means equal, we cross multiply. Denominator of the first fraction to numerator of the second fraction. So 10 times 2 is 20. And the denominator of the second fraction to numerator of the first fraction, 5 times 6 equals 30. 20 does not equal 30, clearly, so these two fractions are not equivalent. So you would say no. If we did 1/6 equals 5 over 30, again, you're going to cross multiply. So 6 times 5 is 30. 30 times 1 is 30. So yes, these two fractions are equivalent. So to determine equivalency, you are going to cross multiply. Now to solve proportions, we solve them the same way. We cross multiply. So let me do a couple examples for you and get you started on this. If I take r over 8 and set that equal to 25 over 40, and we multiply this, 8 times 25 is 200. 40 times r equals 40r. Now notice when I wrote this out, I put them equal to each other, and I didn't create another fraction. But here we have a one-step equation, so we're going to solve this. I divide both sides by 40, and I'm going to get r equals 5. That's what this value would be, r equals 5. Let's look at another one. X plus 4 over 5 equals 3 over 8. Okay. Again, we're going to cross multiply. I'm going to take 5 times 3, which is 15, and then 8 times this quantity. So when I take 8 times this quantity, I'm distributing the 8. So 8 times x and then 8 times 4. 8 times x is 8x. 8 times 4 is 32. And now I'm going to solve this two-step equation. I'm going to subtract 32 from both sides. And I'm going to get negative 17 equals 8x. Divide both sides by 8. And we're going to get x equals negative 17 over 8. And you can leave your answer just like that because this fraction does not reduce. Let's do one more like that, and then I want to talk a little bit about scale model and setting up proportions for that. So let's do 10 over 15 equals 4 over x minus 5. 15 times 4 is 60. 10 times x is 10x. 10 times negative 5 is negative 50. So I'm going to solve this two-step equation, starting by adding 50 to both sides. And I get 110 equals 10x. Divide both sides by 10. And we're going to get x equals 11. So that's basic proportions already set up. The next thing I want to talk to you about is scale model. And if you've ever gotten a model, like a model rocket or a car, it'll give you the scale ratio like 1 to 7. And that would be like every 1 inch equals 7 feet or something to that effect. When you set up anything that deals with scale models or maps, okay, I probably need to get a picture of one of these so I can demonstrate a little bit better how that's going to work. Maybe just 1 second while I flip through here to get the problem for you. And I'll read it and then we'll set it up. So on a map of Florida, the distance between Jacksonville and Tallahassee is 2.6 meters. If 2 centimeters is 120 miles, what is the distance between the two cities? Okay. So I know that every 2 centimeters is 120 miles. Now, when I set this up to find the distance between the two cities, okay, I keep my units of measure uniform as far as where they are in my fraction. For instance, notice when I set this one up, my centimeters were in my numerator. So that means when I set up the second fraction, my centimeters need to be in the numerator of this fraction. And the problem said on the map, the distance between the two cities is 2.6 centimeters. That has to go in my numerator. I have to stay consistent when I set these up. And the question is what's the actual distance? And that's what I'm looking for here. Okay, so the biggest thing about setting these up, you're still going to set up a proportion, but you need to make sure you set them up where your units of measure are aligned as far as my centimeters are in my numerator and my miles are in my denominator. If I'd put my miles up here, then both miles, the 120 and my unknown miles, would be in the numerator and my centimeters would be in the denominator. But from here, we cross multiply, and 2 centimeters, or 2 times x, is 2x. And then I'm going to multiply here. So 120 times 2.6 is 312. Now I'm going to divide by 2, and I'm going to get, divide by 2, 156. So the actual distance between the two cities would be 156 miles. And this is ratios and proportions. If you have questions, please email me and ask. This is how we set them up, and the homework assignment is on Canvas. Thank you.